equation of traveling wave. Suppose if a disturbance at any instant is at this point, so since wave or in wave particle oscillate about their mean position, as well as it may propagate from one point to another. So at some later instant, it will be at this point. So for first part, according to equation of SHM, we can write y equals to a times sine omega t. Now, since this particular wave has displaced by some amount towards the right from this actual position to this point, let's say this is x. So x will be equals to velocity into time taken. So t equals to x by v from this part. Gautam, is it clear?
Yes, sir.
Since this particular wave has displaced by x amount at some time t towards positive x-axis, let's say this is direction of propagation of wave. So if we subtract this particular amount of time from this actual time, then this wave may get to its original position, that is this dot line. So I'm subtracting this time with this one. So you will get y equals to a times sine omega t minus this time, which is x by v. So if you further simplify it, you will get omega t minus omega by v times x. This omega by v is also called k. So we may write it as a sine omega t minus kx is equals to y. So in the above part, we have only one time-dependent term. So it will define you only vibration of particle or oscillation of body about their mean position. But in this part, we have two different terms. One is time-dependent and the other is x-dependent. So it will define you vibration of particle about their mean position as well as its propagation from one point to some other point. So this is called equation of traveling wave. Is it clear? Krishna, any doubt?
So could you explain once more?
Okay. Yes, Gautam?
No, so I was just asking, where can we see traveling wave in real life?
Tell me again.
So where can we see traveling wave in real life?
I'm unable to understand you.
I was asking, where can we see a traveling wave in real life?
In which we are propagating, that is sound. Is it traveling wave or standing wave?
What is actually a standing wave? It's like, doesn't move. Anything which propagates is traveling wave?
Yeah. A wave which travels from one point to another. That is called traveling wave. And if a wave remains at their own position, simply vibrate about their up and down, up and down, up and down, that is called standing wave. So in this part, a wave initially at some time t, it will be at this point. So at some later instant, it may get shifted towards right due to velocity of wave. So it may reach to some new point, this one. So if I have to write this particular point back to its initial term, so you must have to subtract this much amount of time with respect to actual one. So on putting this in this part and simplifying it, you'll get another expression that is called traveling wave. Krishna, tell me your doubt.
No, so the equation, you said
Okay.
something about it. So
Suppose we have this one, which is only time dependent term. So it will define you vibration of particle about their mean position only. That is, there is a particle at this point which is vibrating up and down, up and down, up and down, and nothing more. But according to this part, we can say this particle which is vibrating upon up and down at this point, it may get shifted towards right due to propagation of wave from one point to another. So this particular expression has two different terms. One is time dependent, which define vibration of particle about their mean position. And the next is x-dependent term, which defines you its propagation, its traveling towards x-axis. Is it clear?
yes, sir.
The more general equation related to this part is y equals to a times sine omega t plus or minus k times x. First is y. It will define you displacement of particle. A is called maximum displacement, which is also called amplitude. Omega, angular velocity. K is called angular wave number. So using omega, you will be able to calculate time period, that is 2 pi by t, or frequency 2 pi into f. Similarly, using the value of k, that is angular wave number, you will be able to calculate lambda. Next, we have this x. It will define you direction of propagation of wave. In which direction wave is going. Now we have two different parts, this one plus sign and this one minus sign. This plus sign will define you negative axis and this minus sign will define you positive axis. Like we have a wave which is going along positive x-axis, but in equation we got negative sign. It means this sign has its opposite meaning. Is it clear?
Yes, sir.
Now, this entire part, that is angle of sine, is called phase. Which may depend upon time as well as position in case of wave. So these different things you will be asked to calculate from this particular equation. Gautam, any doubt?
Sir, here lambda is amplitude, right?
Yeah. Lambda is wavelength.
Oh, yes.
K is amplitude. Just write it down.
Sir, can you explain once again why did you put the minus sign near the positive sign? I mean, why did you write minus negative axis near the positive sign and positive axis near the negative sign?
This wave is going towards positive x-axis. So you must have to subtract this much amount of time from this actual path to get this particular wave back to its initial position. That's why there is negative sign in this part. But in actual, the wave is going towards positive x-axis. So if you have sign positive in this part, it means wave will be going towards negative axis. And if you have negative sign in between these two parts, it means wave is going towards positive x-axis. I've just written a generalized equation. In first case, it will be positive at this point. In second, it will be negative at this point. It will depend upon question. Okay.
Okay, sir.
So this is how we can recognize its directional propagation. This sign have its opposite meaning.
Okay, sir.
So the full phrase is the phase. The full omega t plus k x is phase.
Yeah. Phase is simply angle of that trigonometric term.
Okay.
Raza, any doubt? You all have done?
Done so.
Done, sir.
Yusra, done? Okay. Nabila, done?
Yes, sir.
If y equals to 0.04 cos pi times x plus 2 pi by 5 t. Find first time period of this wave, second wavelength, direction of traveling. Just compare this equation to the above part and try to find. First, we have x, so its coefficient will always be k. Next, coefficient of t will be always omega. And the sign in between these two terms will define you its direction of propagation with this variable. Nabila, just tell me in which direction the wave is going.
Along negative axis. I mean, yeah,
Negative which axis? X-axis, y-axis, z-axis?
x-axis.
Good. So we can say direction of traveling of wave is negative x-axis. Gautam, is it clear?
Yes, sir. Sir, x-axis because it is pi x, right?
Yeah. How to calculate time period? Just take the coefficient of t as omega. So omega we have 2 pi by 5. Write omega as 2 pi by t, you will get time period. And similarly, coefficient of x will be k, and k is equals to 2 pi by lambda, then you will get lambda. Try to find these two terms. Krishna, you got any answer?
Yes, sir. For the time period, I got it. So for the wavelength, sir, we should use the formula k is equal to 2 pi by wavelength, right?
Yeah. So if you compare, omega is equals to 2 pi by t, which is 2 pi by 5. So 2 pi cancel out. So t will be 5 seconds. And similarly for next part, k, which is equals to 2 pi by lambda. In this part, we have pi. So lambda will be equals to 2 meter. Mazia, is it clear?
Yes, sir.
Okay, just write it down. You all have written?
Yes.
Okay. Now, next thing in this part will be different term related to this displacement, that is velocity and acceleration. Velocity and acceleration of particle in wave. As we have y equals to a times sine omega t minus of kx, a wave which is going towards positive x-axis having amplitude this. Now in this part, we have two different variables. One is t and the other is x. So to find velocity, you must have to differentiate it with respect to time. So differentiating with respect to t. So this differentiation will be partial differentiation since I'm taking one variable at a time. So it will be represented by del over del t. Y equals to a being constant, keep it outside. Differentiation of sine will be cos omega times t minus kx, in which I'm considering just t as variable. So omega will be constant and differentiation of t will be 1. This del v over del t is called velocity of particle is equals to omega times a cos omega t minus kx. same as for SHM. Now this entire term or the maximum value of cost will be 1. So you will be asked to find maximum particle velocity. So it will be omega times A. Is it clear?
So could you explain the differentiation again?
We have two different types of differentiation. One is actual differentiation and the other is partial differentiation. So suppose if you are differentiating like this, it means this is actual differentiation. So in this part, all different variable x, y, z will be taken as variable. But if you are differentiating like this, so it is representation of partial differentiation. In this part, we'll take one variable at one time. Like we have dt, that is only t will act as variable, the rest of the whole term will act as constant. Is it clear?
Yes, sir.
So since in this particular function, we have two different variables, one is t dependent and the other is x dependent. So I'm differentiating with respect to t only. So only t will act as variable and x will act as constant. So its differentiation will be 0. So I'm not taking that part. Is it clear?
So you just differentiated the sign.
Yeah, differentiating this part. So we have two different terms. First is sine and second is this angle. So differentiation of sine will be cos and differentiation of this angle, which is consisting of two different variables, but I'm taking partial differentiation in which time dependent term. So only this will act as variable, this will act as constant. So its differentiation will be 0.
Okay, sir.
Next, if we further differentiate it with respect to time to find acceleration. So again, differentiating with respect to t, del over del t of particle velocity, omega a being constant, differentiation of cos will be sine omega t minus kx, and differentiation of this part in which omega being constant, keep it outside, and differentiation of t will be just 1. So this term will be acceleration of particle minus of omega square a sine omega t minus kx. So again, we have to calculate its maximum value. So maximum value of sine will be 1. So maximum particle acceleration in wave will be omega square a. Is it clear, Gautam?
Yes, sir.
Okay, just write it down. You all have done?
Yes, sir.
Now, next is you will be asked to define the relation between particle velocity and wave velocity. So let me define you these two terms. Particle velocity and phase or wave velocity. Suppose on a string, a pulse is created or a wave is created like this. So in this part, there will be particle at this point, which will be vibrating up and down about their mean position. Creating a disturbance like this, and this disturbance further propagate along this medium or along this direction with some velocity. So we have two different movement in this part. One is movement of particle about their mean position up and down, which will define you nothing but particle velocity. So first is particle velocity. The velocity with which particle of wave vibrating about their mean position. Raza, is it clear?
Yes, sir.
Next is phase velocity or wave velocity. Suppose a disturbance initially at this point and further at this point. So total distance between two consecutive crests is called one wavelength. And time duration to go from this point to this point is called its time period. So phase velocity is the velocity with which this disturbance may propagate along this medium is called phase velocity. The velocity with which whole disturbance created by particle propagates along the medium is called phase velocity or wave velocity. So velocity is equals to displacement by time taken. So we have total displacement lambda, time taken is t. 1 by t is also called frequency. So it will be lambda times f, and further it will be equals to omega by k. So this will be phase velocity or wave velocity. And for particle velocity, it was omega times A cos omega t minus of kx. Gautam, any doubt?
No, sir.
Okay, just write it down. Minashi, any doubt?
No, sir.
So did you get V is equal to W by K just from K is equal to W by V? That one there.
You may write omega is equals to 2 pi by t and k is equals to 2 pi by lambda. Is it clear? Now just divide them. So 2 pi and 2 pi will cancel out. So you'll get lambda by t. Is it clear? Okay.
Yes, sir.
Nabila, done?
Yes, sir.
So can I see what you wrote in black again? Just got cut. So the W by K one. Just I want to see.
Okay,
that.
just 1 minute. It's omega.
Okay, sir.
Okay. Now, if you have to relate these two parts, so first question will be to find a ratio of maximum particle velocity and phase velocity. So velocity of particle maximum, it will be omega times A, and wave velocity equals to omega by k. So just divide them. Omega and omega will cancel out. So it will become k times A. K is also called 2 pi by lambda. So your answer will be like this. Next, how to relate these two terms, particle velocity and wave velocity. As y equals to a times sine omega t minus of kx. So if you differentiate it with respect to x, that is del y over del x, a being constant, differentiation of sine will be cos omega times t minus kx. And next differentiation of this particular angle, in which I'm taking x as variable. So coefficient of x is minus k, it will be outside, and differentiation of x will be 1. Gautam, is it clear?
Yes, sir.
Now this particular quantity dy dx, suppose if we have this as y and this is x and any curve to this point. So if you want to calculate slope to this particular curve, perpendicular line will be dy and horizontal line will be dx. So dy over dx will define you nothing but slope of this particular curve. Similarly, from this part, we can say this is slope is equals to minus of k into a cos omega t minus kx. Now just divide these two parts, particle velocity and slope. So particle velocity divided by slope of curve at that instant, it will be omega times a cos omega t minus kx divided by minus of ka times cos omega t minus kx. So common term will get cancelled out and you will left with just minus of omega by k, which is nothing but velocity of wave. Krishna, is it clear?
Yes, sir.
Sir,
Yes.
why are we dividing velocity max by v?
There will be a question related to this. You'll be asked to define the ratio of maximum particle velocity and phase velocity. So relation will be like this.
Okay, sir.
Now from this part, velocity of particle will be minus of slope multiplied by velocity of wave. So this is the relation between particle velocity and phase velocity. Now from this part, you'll be asked a question. Suppose a wave is propagating along this. At any instant, there is a particle at this point, let's say A, and at this point, let's say B. So you'll be asked in which direction this particle A will be going at this instant, whether it will be going upward or whether it will be going downward. Similarly, what will be the direction of propagation of this particle at B, upward or downward? So how to define? So for these type of problem, just draw a tangent to that particular point for which you will be asked. Suppose at this point. Now try to calculate inclination of this particular point. So here inclination we have negative. Let's say it is θ1. Is it clear?
Yes, sir.
According to the above formula, velocity of particle at point A is equals to minus slope. Slope is nothing but tan theta, and we have minus theta, so it will be minus of tan θ1 multiplied by velocity of wave. Now this minus and this minus will become plus times tan θ1 multiplied by v. So it means velocity of particle at point A is in positive, so it means it must be going upward. Gautam, is it clear how to define direction of vibration?
Yes, sir.
Similarly, if you have to calculate for point B, just draw a tangent to that point, draw a horizontal line and define its inclination. So it is positive. So velocity of particle at point B is equals to minus slope, which is in positive, multiplied by its velocity v. So you'll get minus of tan θ2 v. So at this point for B, we are getting particle velocity is in negative. It means it must be going downward at this instant. Nabila, is it clear? Raza, any doubt?
No, sir.
Okay, just write it down. Have you all done?
Just a minute. Done, sir.
Now, next question will be about phase difference, part difference, and time difference. Next is relation between phase difference, part difference, and time difference. As y equals to a times sine omega t minus of kx. So in this part, this entire thing is called phase. So phi is equals to omega t minus of kx. In first case, let's say t is constant. And second, let's say x is constant. So phi1 equals to omega times t minus of k at some position x1. Similarly, phi2 equals to omega times t minus of k times x2 at some position x2. So if you subtract these two parts, minus, minus, and plus, this term and this term will get cancelled out. Phi1 minus phi2 equals to k being constant, keep it outside. So it will be x2 minus x1. This term is nothing but change in angle. So it will be termed as phase difference. Delta phi equals to k. This is change in position to termed as path difference. You may transform this k as 2 pi by lambda times delta x. So this is phase difference in relation with path difference. Mazia, any doubt?
No, sir.
Similarly, in second part, I'm taking x to be constant. So phi1 will be equals to omega times t1 times kx at some instant t1. And similarly, phi2 equals to omega times t2 minus of kx. So if you subtract these two parts, minus, minus, and plus, this term and this term will cancel out. So phi1 minus phi2 equals to omega being constant, t1 minus t2. So it will be delta phi equals to omega times delta t. We may write omega in terms of time period, 2 pi by t times delta t, or in terms of frequency, it will be 2 pi f times delta t. So this is phase difference in relation with time difference. So there will be direct question related to this particular formula to find phase difference in relation with path difference and time difference. Gautam, any doubt?
No, sir. But why are we taking the t constant in first case and x constant in the second case? How can we do that? On what basis?
Since we have two different variables and we are considering partial differentiation, so we have to take one variable at a time. That's why I'm taking first t is constant in first part and then x is constant. We have to take each term to be variable at just one time. Is it clear?
Okay.
Nabila, done?
Yes, sir.
Okay. If y equals to sine pi by 4 times x plus 2 pi t, find first phase difference for delta x is 25 centimeter, phase difference for delta t 1 by 2 seconds, and third, velocity of wave. Use the above concept and try to find Raza, you got any answer? From this relation, we may write coefficient of x as k and coefficient of t as omega. So k is equals to pi by 4 radian per meter, and omega we have 2 pi radian per second. So phase difference for part difference delta x is equals to 25 centimeter. So delta phi equals to k times delta x. K we have pi by 4 and delta x is 25 centimeter. So first convert it into meter. So it will be 25 by 100. So it will become pi by 16. Nabila, is it clear?
Yes, sir.
Similarly, in case of time, delta phi equals to omega times delta t. Omega we have 2 pi and time difference is 1 by 2. So 2 and 2 will cancel out. So phase difference will be pi. And third, velocity of wave is omega by k. Omega we have 2 pi and k is pi by 4. So pi and pi will cancel out. So 2 into 4, it will be 8 meter per second. Krishna, is it clear?
Yes, sir.
Gautam, any doubt?
No, sir.
You all have written?
Yes, sir.
Yes, sir.
Okay. Now the next is reflection of wave. Suppose a pulse is incident towards a movable support like this. This is free end, and pulse is projected towards it. Let's say this is incident wave. So on reaching this particular pulse to this end, this free end will vibrate according to the shape of this particular pulse. So there will be no change in its direction of vibration, and on reflection, it will get reflected like this. So we may write equation of these two terms. First, y incident, which is going towards positive x-axis. So it will be a times sine omega t minus of kx. And next, reflected part, which is going a times sine omega t plus kx. So both are differ only in direction. Their phase difference will be 0. So you'll be asked, what will be the phase difference if a string is connected to free end and a pulse or a wave is created over it on reflection? So you'll say phase difference in this case will be 0. But suppose in second case, if it is connected to fixed end at this point, so on reaching this particular pulse to this point, there will be no any movement up and down according to the shape of this particular pulse. So on reflection, it get reflected back, but in opposite direction and also in opposite phase like this. So this is incident and this is reflected. So according to this part, y incident is towards positive x-axis, a times sine omega t minus of kx, and y reflected is a times sine omega t plus kx, and both are different phase by pi, so there will be pi. And this also equals to minus of a times sine omega t plus kx as well. So from this part, we can say phase difference in between these two terms is pi. Nabila, is it clear?
Yes,
Yusra,
sir.
any doubt?
So what is it? What does it mean? A free end and a fixed end. The end is also free to move. That's what it means.
Yeah. At this point, this is free end. So if this particular pulse reaches to this point, this particular free end may vibrate according to the shape of this particular pulse, so that there will be no change in its direction on reflection. It gets reflected back in just opposite direction with the same amplitude in upward way. But in this part, since this is connected to fixed end, so it will tend to move this particular pulse downward on reflection. Hence, phase get differ in phase by pi.
So why do we say it's by pi?
Okay, why is it pi? I'm defining this. Just write it down.
Sir, Also in the first one, if we subtract omega t minus kx and omega, won't we get minus 2 kx?
No. This particular sign is defining nothing but its direction. Okay. This part is to define along positive x-axis, and this is to define its direction along negative x-axis. Okay.
Yes, sir. And if we subtract them, we won't get 0, right? Because of the signs.
But this is due to the direction of propagation. This is going towards positive x-axis and this is going towards negative x-axis. There's no anything other than this part to define its actual phase difference. This is to define its direction of propagation. Okay.
Okay, sir.
Done, sir.
Raza, you may take screenshot.
Okay, sir. Done, sir.
Now, using this concept, we have to define another term, that is standing wave, in which I'm defining this phase difference. Standing or stationary wave. Suppose between two fixed end, a wire or a string is connected and a wave is created like this. Since this particular end is fixed, so on reflection, it will get reflected in opposite direction. If you proceed it towards backward to reach at this point. Now draw projection at this point and this point. Both are along same direction. So difference between these two parts is nothing but pi. That's why we can say a reflected and incident wave differ in phase by pi. Is it clear?
So could you tell again?
Whenever you have to calculate phase difference, just keep one of the wave as its initial position and move the next wave towards backward to get same shape. So we have same curvature to this point and same related to this part. So if you draw projection this both are identical to each other. So difference between these 2 points is pi. As for total from this point to this point for complete wave, it will be 2 pi. That's why we can say this incident wave and this reflected wave get phase difference by pi. Is it clear?
Yes, sir.
I had also defined this particular concept in SHM to define velocity, displacement, and acceleration phase difference. Now from this part, let's say incident wave is going towards positive x-axis, having amplitude a times sine omega t minus of kx, and y reflected a times sine omega t plus kx, and differ in phase by pi. That's why it will have negative sign. Krishna, any doubt?
No, sir.
Now, on adding these two terms, parts, y equals to y incident plus y reflected. Take out a as common. So you're left with sine omega t minus kx minus sine omega t plus kx. Now, how to simplify it? One way is to expand this particular relation, this part and this part, according to the formula sine a plus b or sine a minus b, and just simplify it. The next way is to take this entire term, single part. Suppose this is c and the other is d. So it will be 2 times sine c d divided by 2 cos I'm considering c to be larger. So this is c and this is d. So we have negative sign with c and positive sign with d. So it will have negative, positive. So here we have negative and then positive. Gautam, is it clear?
So I think we
This
don't
is
understand the formula.
This is identity of trigonometry. You have to just remember it, okay?
Okay, sir.
So using this part, if you simplify it, so y equals to a, on adding these two parts, you will get, here it will have negative 2 sine c plus c minus d. C we have omega t plus kx minus d, which is omega t minus minus plus kx divided by 2 cos c plus d, that is omega t plus kx plus omega t minus kx divided by 2. So it will become minus of 2a. Omega t and omega t will cancel out. Kx and kx will cancel out. So you will get in first part kx, 2kx divided by 2, just kx. In second part, omega t is 2 omega t divided by 2 is just omega t. So this is your final expression of standing wave or stationary wave. Now from this part, you will be asked how to distinguish traveling wave and stationary wave. Let me show you, just 1 minute.
So how did we take c minus d and c plus d? What was the reason for that?
Yes.
So what was the reason for taking c minus d and c plus d?
If we have sine of this whole angle to be one term and sine of this whole angle to be one term, so we consider this particular larger angle to be c and smaller angle to be d. So identity related to this particular subtraction will be this. We can prove this particular identity using sine of a plus b as well.
Okay, sir.
Till now, just you remember this particular part. Okay?
Yes, sir.
So can't we do the other way around, like sine d minus sine c?
The other way is to simply expand this particular relation using the concept of sine of a plus b or sine of a minus b, which we have used in SHM part also. Sine of A plus B is equals to sine A cos B plus cos A sine B. And similarly, sine of A minus B is equals to sine A cos B minus cos A sine B. If you expand the above relation according to this formula, you'll get the same result. So it will depend upon you, which is more easier for you. Gautam, is it clear?
Yes, sir.
You may expand the above relation according to this formula, or you may use single one directly. Now, the result part. In this term, we have two different terms. One is time dependent and the other is x dependent. Both are separately written with respect to one another. But in case of traveling wave, for any traveling wave like this, both kx part and omega t part must be within the same bracket. So this is the main difference how to distinguish between traveling wave and standing wave. Is it clear?
So could you repeat?
If both kx and omega t are written in same bracket with just one function, then it will be termed as traveling wave. And if omega t and kx are written separately with two different functions, then it will be termed as stationary wave. Is it clear?
Got it, sir.
Yusra, any doubt?
No doubt, sir.
Okay. Just write it down. I'm giving you just 5-minute break. Okay. You have allowed, you will have written. Just write it down. Krishna, any doubt?
No, sir.
Now, related to this part, you will be asked, if y equals to 0.06 sine pi by 2 times x cos pi by 4 times t. Is it standing or traveling wave? Find amplitude of actual wave. Minashi, just tell me, is it standing wave or traveling wave?
Standing wave.
Good. So what will be the amplitude related to this part? Just compare to the above one. In a standing wave, the resultant amplitude becomes twice as that of individual wave. So using this concept, we can say 2a is equals to 0.06. So a will be equals to 0.03 meter. Gautam, any doubt?
So what is meant by actual wave? Oh, got it, got it.
Just see. Standing in a stationary, what we are calculating in this entire term. Mazia, any doubt? Okay. You all have written?
Yes, sir.
Now the next thing is, in this particular graph, we have two different parts. There is a point where displacement of particle is maximum, that is at this point. So this is called antinode. And there is another point where displacement of particle is minimum, that is this. So this is called node. So how to define position of node and antinode on this string? You will be asked. So from the above relation, we have y equals to 2 times A sine of kx cos omega t. So in this term, we have two different segments. One is time dependent and the other is position dependent. So this position dependent term will define you position of node and antinode. In case of node where amplitude is minimum, that is 0, so sine of kx will be 0. So general value of sine for which it is 0 is n pi. So sine of n pi will be always 0. So if you compare these two terms, you will get kx is equals to n pi and x is equals to n pi by k. So if you substitute k is equals to 2 pi by lambda, you will get n lambda by 2 as position of node. So if you put n equals to 1, 2, 3, 4, so position of node will be lambda by 2, 2 lambda by 2, 3 lambda by 2, and so on, and 0 also. So these are different position of node on the string. Similarly, in case of antinode, where amplitude is maximum, so maximum value of side will be 1, and for it, it will be 2n plus 1 pi by 2. So on comparing, you will say kx is equals to 2n plus 1 n pi by 2. So x is 2n plus 1 pi divided by 2k. If you substitute k is equals to 2 pi by lambda, you will get 2n plus 1 lambda by 4. Now put n is equals to 0, 1, 2, 3, so on. You will get lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. So these are different position of antinode on the string. Gautam, any doubt?
No, sir.
Just
First,
remember only this
what are you
part.
substituting? Oh, you're substituting 0. Okay. So, but why are we taking n pi and 2n plus 1 pi by 2?
This is general value for sine to be maximum and minimum.
Oh, okay, sir.
Done, sir.
Raza, any doubt?
No, sir.
Now, we have to define this particular superposition in one more part that is called beads. So first, what do you mean by bead? Let me define you using graph. Let's say one of the wave is at this A. Number of complete oscillation in 1 second, I'm supposing 4. So its frequency is 4 hertz. Another wave in this part, we have two complete oscillation from this point to this point. Let's say this is B and frequency of this is 2 hertz. Now, if they superimpose over one another, direction of wave initially is along this direction, and for this part, it is along this direction. Both are along same direction, so they will tend to add up, so amplitude will start increasing. At this point, direction of this pulse and this pulse in opposite direction, so they will tend to subtract it. Similarly, at this point, they will further add, and at this point, they will get subtracted. So if you superimpose according to this relation, you will get now in this part, we have two different terms. One is a position of maximum amplitude. You can call it as loud sound. Another position having amplitude minimum, which is called faint sound. Now, beat is nothing but combination of a loud sound and a faint sound. So from this part, we can say from this point to this point, it having one loud and half faint on both sides. So it will become one complete faint. So it is 1B. Similarly, from this point to this point, one loud and one faint. So it will be 1B. So
So
in
why are
total,
the faints considered in half?
this is starting from this point and end at this point. So if may you consider from this point to this point is one half, and from this point to this point is other half. And this entire region is one complete loud sound. Or you may consider one complete wave in which we have two segments, loud sound and a faint sound. Is it clear?
Yes, sir.
This combination of a loud sound and faint sound created by two waves which having different frequency when superimposed over one another create beats. So what do you mean by beat? So you'll say when two waves of different frequencies superimposed over one another would create combination of loud sound and faint sound. This combination is called beats. First, draw this, then I'm defining you.
Done, sir.
1 second, sir. Done, sir.
Now in this part, just count a number of complete oscillation for this red one. We have two complete oscillation. And if you just subtract these two frequency, 4 hertz and 2 hertz, you will get exact 2 hertz. So we can say this is nothing but difference of frequency of source. Now, just count this particular green wave. How many complete oscillation it have? You will get 6. And this is nothing but sum of frequency of these two source. Is it clear? I will
Ye-
define you its physical interpretation and its equation. So first, what do you mean by beat? So you'll say, when two waves of different frequency superimpose or overlap over one another will produce combination of loud and faint sound. This combination is called beat, and the number of beat produced by wave per unit time is called its beats frequency. Next is number of beats used by wave per unit time is called beats frequency. Now let me define you mathematically this particular part. First, write it down.
Sir,
Yes,
so what is F2 minus F1 minus F2 and F1 plus F2?
in this part we have F1 equals to 4 hertz and F2 equals to 2 hertz. So in this particular formation, this red one complete oscillation and 2 complete oscillation. So from this point to this point, we have just 2 hertz for this red one. So which is nothing but difference of frequency of two wave, we can say. Is it clear?
Yes, sir.
And according to number of beat, it have so 1 beat and 2 beat. So how many beats are there from this point to this point? 2 beats. And number of beats produced by wave per unit time is also called beats frequency. So we can say in this formation, beats frequency is 2 hertz, and which is nothing but difference of frequency of two wave. Is it clear?
I think I didn't get it, sir.
Is it clear how it is F1 minus F2?
Because it is 2 hertz.
Yeah. And the difference of these two sources must be 2. 4 minus 2 is 2. Is it clear?
So, but why is there red line and a green line separately?
Since we have two different wave and having different frequency, so on superimposition, it will create you two different wave. Let me show you mathematically so that it will be more clear for you. Let's say we have y1 a times sine omega 1 t. It will be a sine omega is 2 pi f into t, and y2 equals to a times sine omega 2 into t. So it will be a times sine 2 pi f into t. So on adding these two terms, y1 plus y2, take out a as common. So you'll get sine 2 pi f1t plus sine 2 pi f2 into t. Now we have two different angles. Let's say this is C and this is D. So it is sine of C plus sine of D. So according to the above formula, we may write it as y equals to 2 times A sine C plus D by 2. So it will become C plus D divided by 2 cos C minus D divided by 2. So if you simplify it, you will get 2a sine. Take out 2, so it will get cancel out. So you'll get f1 plus f2 times t. And in second part, you will get f1 minus f2 times t with pi. So this is final expression of this particular beat, in which we have two different frequency. One is sum of the frequency and the other is difference of frequency. That's why on superimposing two different wave having different frequency, you will get two different wave, in which one of the wave will be vibrating with a difference of frequency and the other wave will be vibrating with sum of frequency. Is it clear?
Yes, sir.
That's why in this part we have two different curves. The red one is defining you the difference of frequency of two source, and the green one is defining you the sum of frequency of two wave. Any doubt?
No, sir.
Krishna?
So this one is possible only in standing wave.
No, no. Only if the frequency of two source is different.
Okay, sir.
Just write it down from this part. Have you all written?
Yes, sir.
Yes, sir.
1 second, sir. Done, sir.
Now from this part, we can say beats frequency is equals to difference of frequency of two wave. So it will be F1 minus F2 or F2 minus F1, depending upon their difference to be positive. That's why in above part, we have two beats. And since I've just considered this entire term to be in 1 second, so you can call it as 2 hertz, and which is nothing but the difference of frequency of two wave. Gautam, any doubt?
No, sir.
So this is all about this your entire syllabus, that is wave. So we have alhamdulillah finished it. So from next class onward, we'll start revision. Okay.
Okay, sir.
Okay, sir.
Okay then. Thank you.
Thank you, sir.
So one second, can you
Thank
please
you, sir.
scroll up just for a second? The topic just above beats. Done, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir. Sir, can you please show the last line? Okay, thank you, sir.